Second, all right, example 4, they ask us to do a composition of functions. They ask us to evaluate the cosine of arctan 1 plus arc cosine x. So they're putting a composition of functions together with our cosine addition rule that we learned yesterday. All right, so if we've got cosine addition, that's cosine u plus v. Then yesterday we learned that was cosine u cosine v minus sine u sine v. We memorized that last night. Yes, we memorized that last night, right? Right. Okay, so we're going to go through and we're going to put arctan 1 in for each u, and we're going to put arc cosine x in for each v. All right, so now we need to start evaluating. The first piece that they asked me to find here is the cosine of the arctan of 1. So that's a composition with inverse functions. That takes us back to like section 4.7 and 4.8. So it's been a little while. So let's review back through that. When we see cosine arctan 1, we're going to start on the inside. So from that inside piece, I can say arctan by definition means tangent is equal to 1, and I only have first and fourth quadrants to choose from. I get all that from the definition of an inverse tan function. Okay? So looking at that, I'm going to say, all right, if tangent is opposite over adjacent, I can build a triangle here and do a squared plus b squared is equal to c squared to get my other side. We had said that when you had these compositions, there were two things that you had to get from that inside piece of information. You had to get the values of the triangle, so we've got that. You also had to get the quadrant that you were in. So we go back and look at this and say, okay, if it's inverse tangent, it's only valid in the first and the fourth. It's positive in the first and negative in the fourth. So since this was a positive 1, I have to be in the first quadrant. So now I'm done with that inside piece of information. Now I can answer the question that was asked about it. What is the cosine of the arctangent of x? So if I'm looking for the cosine, I can come down here and say cosine is adjacent over hypotenuse. That'd be 1 over the square root of 2. And of course we would rationalize that to be square root of 2 over 2. Then also we would say, since I'm in the first quadrant, I know that this is positive. The second thing that they asked us to do with that arctan was, once we figured out arctan 1, to then go back and say what is the sine of arctan 1. So same story, I can come down here to my triangle again and say sine is opposite over hypotenuse. That's 1 over the square root of 2, so we'd have to rationalize that, and we'd get square root of 2 over 2, right? So now we've got that value that we can plug in, square root of 2 over 2. Now, we did this based on triangles, but you also could do this based on the unit circle, right? Where you could say, if I have arctan 1 where I'm saying where is tangent equal to 1, my reference angle would be pi over 4. And then I could say, okay, first or fourth quadrant, well, in the first quadrant, it would be pi over 4. So then, once I know that I'm working with pi over 4, I can say, what's the cosine of pi over 4? And then over here, same idea, what's the sine at pi over 4? So it doesn't really matter to me if you choose to use the triangles or the circle. It's going to lead you to the same answer, whichever you prefer. All right, so we've got this square root of 2 over 2 value and this square root of 2 over 2 value, but now we still need to go back and find cosine of arc cosine x and sine of arc cosine x. So let's talk about arc cosine x. By definition, that means that cosine is equal to x, and I only have first and second quadrants to choose from. Again, I get all of that from the definition of arc cosine. So I'm going to build a triangle. I don't have a choice this time because I don't have a value off the unit circle I can use. So if I build a triangle, I'm going to say, okay, cosine is adjacent over hypotenuse, Pythagorean theorem to get the other side. Then, because this was a positive x, I know I have to be in the first quadrant, because if it were a negative x, I would have been in the second quadrant. So the two pieces of information that I have to get from the inside arc cosine x is that I have to get the values for my triangle, and I have to get the quadrant that I'm in. So we've got both of those things. So now we can go back and answer the question that was asked. What is the cosine of that? And what is the sine of that? So let's find the cosine and the sine based on that information. So looking at this, cosine is adjacent over hypotenuse, so that would give us x, and in the first quadrant it would be positive. And sine would be opposite, the radical, over hypotenuse. So we would just have radical over 1 or radical. And so we can come up here then and say, okay, we found the cosine of the arc cosine was x, and we found the sine of the arc cosine was the square root of 1 minus x squared. A shortcut that we could use here, if you notice cosine and arc cosine are inverses of each other, they would cancel each other out and just give me x if I was within the designated region for inverse cosine, which is first and second, and I was. So therefore I could have just canceled those out and given x. That would have been another way to do that part of the problem. So again, pulling something that we did back in chapter 4, combining it with this topic that we were learning yesterday in chapter 5. All right, here's another one. Look at example number 8. For example number 8, they are literally asking me to do 3 problems in one. Because here I have a sine addition problem, here I have a sine subtraction problem, and then here they're asking me to solve and find out where that's equal to -1. So we're going to do sine addition and sine subtraction, which would have been 2 problems in themselves, and then we're going to combine that with section 5.3 where we were solving these trig equations. Okay, so again, higher thinking skills, doing multiple problems within the same exercise. So let's start with this guy, sine x plus pi over 4. That's our sine addition formula. So that's going to be sine cosine plus cosine sine. And we're going to put in our x in the first place, and we're going to put in our pi over 4 in the second place. So it'd be like sine u cosine v plus cosine u sine v. All right, then we've got sine subtraction. So our sine subtraction formula is sine cosine minus cosine sine, where again we're going to put x in the place of u and pi over 4 in the place of v. So it'd be like sine u cosine v minus cosine u sine v. All right, so let's simplify a little bit of what we've got. Notice that over here we have a positive cosine x sine pi over 4, and over here we have a negative cosine x sine. All right, so our cosine x sine pi over 4 and our negative cosine x sine pi over 4 are going to cancel each other out. So that would leave me with just sine x cosine pi over 4 and sine x cosine pi over 4. All right, we know the cosine at pi over 4, so let's go ahead and slot that in. Cosine at pi over 4 is square root of 2 over 2, so we can put it in here, and we can put it in here. So now what we have is 1 square root of 2 over 2 sine x plus 1 square root of 2 over 2 sine x. So that would give me 2 square root of 2 over 2 sine x's. One more time, I have 1 square root of 2 over 2 sine x plus 1 square root of 2 sine x. So that's going to be 2 square root of 2 over 2 sine x's. And we want to know where that's equal to -1. All right, so our 2's are going to cancel each other out, and that would leave us with just square root of 2 sine x is equal to -1. Remember when we were solving these before, we tried to get sine x on one side by itself and everything else on the other side. So I'm going to divide by this square root of 2. So that would give me sine x is equal to -1 over the square root of 2, and of course I'd rationalize that, so I'd get negative square root of 2 over 2. So now we can say, okay, step number 1, what's my reference angle? And then because this was negative, I can say sine is negative in the third and the fourth quadrant, so I can give the third quadrant pi over 4, which is 5 pi over 4, and the fourth quadrant pi over 4, which is 7 pi over 4. All right, last thing that we want to look at, example number 7, is a verify. And you'll notice the icon there on example number 7 shows that this is an application from calculus or something that we would use in calculus. So this one is a verify. They ask me to verify that sine x plus h minus sine x over h is equal to this string over here. So I'm going to start over here with sine addition. So sine addition is sine cosine plus cosine sine. That's that same formula we learned yesterday. And when I get there, I'm pretty much stuck. I mean, if you look at it, I don't have any Pythagoreans, so I can't replace, I don't have any squares to replace. I don't have a fraction to combine because it's already one single fraction. Everything's already in terms of sine and cosine, so really the only thing I have left is factor. And I do notice that I have a sine x here and a sine x here, but that's honestly the only thing I have in common. I could take a sine x out of those if I kind of reorder my problem here. And what I mean by that is, if I take this sine x cosine h and move it to the back and shift these other two pieces up, so it's kind of like if this is numbered 1, 2, 3, it's like we take number 1 and we put him in the very back and we scoot number 2 and number 3 up. I haven't changed anything because this is still cosine x sine h minus sine x plus sine x cosine h, because that was an added piece there in the front. I can add it to the back just like I had it added to the front without changing anything. Why would I want to do that? Well, because then I can factor out that sine x that I had in common in these two pieces. So I'm going to take out that sine x, and when I do, I'm actually going to take out a negative sine x. So negative sine x divided by negative sine x would be 1. And sine x cosine h divided by negative sine x is going to leave me negative cosine h. You can see if you distribute that back through as well that it takes you back to what you had in the previous step. All right, when I get there, I'm really stuck. I mean, I honestly can't think of anything else that I can do. And so I'm going to take my answer and I'm going to bring it down here to the bottom and start trying to work my way up. And I notice that this is 4 separate pieces. And so that would give me the first clue that, hey, I need to break this fraction apart into 4 separate pieces. So that's what I'm going to do. I'm going to put cosine x sine h over h. So cosine x sine h over h. If I'm going to break that into 2 separate pieces being multiplied, one of them is going to keep the denominator of h, and the other one's just going to have a denominator of 1. How do I know where to put it? I'm literally just looking at my answer down here and seeing, okay, the h needs to go with the second piece, so the 1 needs to go with the first piece. Same idea over here. I've got a second term that I could write over the common denominator of h. So I've got sine x 1 minus cosine h all over h. And to break those two pieces apart, I'm going to put the h with the 1 minus cosine h and put the 1 with sine x, again, just because I'm trying to work my way towards that answer. That's the only way that I know how to do that. All right. So here is our homework for tonight, continuing on with the same section. On pages 408 and 409, we're doing 3, 11, 23, 41, 47, 51, 55, challenge 84.